So we're going to look at another question from the 2020 HSC Advanced Maths paper. So this is question 29. We're given a graph of the line y equals c times the natural log of x. C times the natural log of x. We're told c has to be greater than 0. We're asked to show the equation of the tangent to this function at the point where x is equal to p, where p is greater than 0, is that formula. So what we're going to do first is we're going to find the slope of the tangent to this function. So we need to find the derivative of y. So we have dy dx. Now the derivative of the natural log is 1 on x. So this becomes a constant, c over x. This is the derivative. Now at the point where x is equal to p, dy dx where x equals p is c over p. This is the slope of the tangent line. We also know, so that here we found the slope, we also need a point that this tangent passes through. Well, it passes through the point where x is p. If x is equal to p, this implies that y is equal to c times the natural log of p. So now we have a point. We have p, c, ln p, and we have a slope, c on p. And now we can just plug these into y equals mx plus b. So y equals mx plus b. This implies that b is equal to y minus mx. We have y, m, and x. All we need is b. So b is equal to y, which is c ln p, c natural log of p, minus m, which is c over p, multiplied by x, which is p. The p's cancel here. So therefore b, the y-intercept of the tangent, is going to be c times the natural log of p minus c. So now we have the slope m up here. We have the y-intercept b down here. We just need to plug them back into the form. So the tangent line is going to be y equals c on p times x plus b, which is c ln of p minus c. Now this is the answer, but we could rearrange it. Y is equal to c on p times x minus c plus c ln of p. And this is the answer. So this is the answer to part A. Now part B, we are told find the value of c such that the tangent from part A has a gradient of 1 and passes through the origin. So gradient of 1 and passes through the origin. Well, gradient of 1 means m equals 1. M is c on p. So this means c on p equals 1. This implies that c is equal to p. So immediately we know a condition which will satisfy the value of c such that the tangent from part A has a gradient of 1 and passes through the origin is the condition that c is equal to p. Passes through the origin means x is 0 and y is 0 will be a point that satisfy this tangent line. So x is 0, y is 0 implies that 0 is equal to c on p times 0 minus c plus c ln p. This is 0, this is 0. Add c to both sides. We get c is equal to c times ln p. We can divide both sides by c, and this gives us ln of p is equal to 1. Well, this is the point where p is equal to e, because the natural log of e is 1. And we know that if p is equal to e, c is going to be equal to e as well. So we identified c was equal to p. We plugged in the origin to the line of best fit. This yielded the result for us that ln of p must be equal to 1. This implied that p had to be equal to e because P had to be equal to E, C had to be equal to E as well. So therefore, the value of C has to be equal to E. And this is the answer. In terms of the marking, this is a 4-mark question. The marking will work roughly as follows. You will get 1 mark for making substantial progress towards showing that the equation of the tangent is the formula listed. So this could vary a little bit. The markers will decide what they think is sufficient working in the marking center, but because it's 2 marks at the beginning, 2 marks at the end, you will get marking for sufficient working, and then you'll get marking for being able to demonstrate with correct working that that is actually the equation of the tangent. For the second part, so the second part is also 2 marks, find the value of C, you will have working that starts to find the relationship of C to other variables. So that will be, this was the second mark for the first part. The first mark for the second part will be something like finding that C is equal to P, or finding that P is equal to E, or something along those lines, and then correctly identifying that C is equal to E.